beautiful pre-algebra students. I've had quite a few technical difficulties getting yours ready today, so here we are with another try, and I know this is going to go great, but I really appreciate you and all your hard work. I hope you're having a great day. This might be published just a couple of minutes late, but this is because, as I said, some technical difficulties. The other one was choppy and jumpy, so I wanted to make sure that this is very good for you. So we're going to take a look at solving equations with variables on each side today, but before we do that, I want you to warm up. So please warm up with these problems. Don't forget to do the same thing to both sides of the equations to try to get the problems to work out. What I would like you to do is I would like you to first of all just work these problems and make sure you solve them and you check them. Pause the video so that you can do them on your own and then resume the video once you have had a chance to do them. And your video would be paused now, but right now I'm going to move right along and remind you that you can subtract 5 from both sides. Remember, both sides always for everything. That gives us that the opposite of b is 7. That would mean that b would have to be -7. In order to check it, don't forget you plug it back into the original equation. Minus -7 plus 5. Minus negative makes +7 plus 5, that will equal 12. And then we can move on to doing this one, -5 on both sides. And notice I'm always going to say on both sides. And when we divide both sides then by 3, we get m equals 4. And we can check that. Once again, plug it into the original equation, 3 times 4 plus 5, to make sure that you get the right answer, which is 17. So our answers are actually like the b equals 7 and the m equals 4, just to remind you. Don't forget in these that there's a hidden grouping symbol. So to solve this, I'm going to multiply both sides by 7 and get w plus 2 equals 21. Subtract 2. So w equals 19 is my supposed answer, but we check it out anyway. 19 plus 2 over 7 is 21 over 7, which does give me 3. So there's our answer there. On this one, what we can do is we can group the symbols again, multiply both sides by 3 to undo the dividing. So that leaves me with these canceled. -8 plus a equals 18. Add 8 to both sides of the equation. So that a equals 26. We can check it then by plugging back into the original, -26 plus, so 8, I'm going to restate that. -8 plus 26 over 3 gives you 18 over 3, which does give you 6, which fits with the original question. Now let's move on to something new. When you're solving and you're trying to get the variable by itself, even if you've got decimals, even if you've got something that looks a little more difficult, what you need to do is maintain the integrity of this equal sign. We need to subtract from both sides in order to get it so that you have a variable only on one side. It doesn't matter if it's on the left or the right, but you don't want the variable on both sides, just one. So we need to do this, 7 minus 2.5. Remember, we have to add a 0.0 for that. And then we need to borrow. So that gives us 4.5n. This is a little bit more of a complicated problem, but I'd rather give you something that's a little bit more to think about. So we'll take away 12 from both sides. Don't forget -2 minus 12, if you're heading down on the number line, would take us to -14. So we have 4.5n equals -14. We'll then divide by 4.5. And when you divide by 4.5, don't forget 14 divided by 4.5. You can move that decimal over. Once you've moved the decimal point over, you have an ending point. If I multiply this times 3, I'm going to get 135 with 5 left over. And since we moved the decimal over, you can say 5 out of 45. It should be dawning on some of you that 5/45 can be reduced because both are divisible by 5. You do divide it by 5 and divide it by 5. So your final answer will be 3 and 1/9. And that will be your final answer for this. Right now we're working on the solving of the problems. Yes, you could do the check. The check for this one's quite lengthy. So right now we're just trying to get you to be able to work carefully, solving, putting the answer on both sides. On this one, once again, you're trying to get the variable gathered up on one side before you actually do the other. So we need to make sure that you take away 3x from both sides, because then it's gone from over here, and you have 2x minus 6 over here. You work furthest away from the variable first once you've got it on one side. So we're going to add 6 both places. 2x equals 15. I need to divide both sides by 2. So x will come out to be 7 and a half on this one. And moving right along, if we're taking a look at this one, I do pause the video and try to do this on yourself, but we're going to just keep this moving right along. And so what we can do now on here is we can take away 2r from both sides. Another trick might be to add 6r to both sides. It doesn't really matter as long as you are careful. And you do the same thing to both sides. -6 minus 2. You're at -6. 2 more to the left takes you to -8. You're then going to take away 12 from both sides and get -8r equals 24. So let's divide both sides by -8. Positive divided by negative gives you a -3. You have a very nice solution there. Not all of them end up with decimals and fractions like the last ones. We'll take a look at this one. We want to get the d on just one side, so I'm going to take away the 15d. That leaves us with 3d over here. Haha, 3d. Put on your glasses. I know, corny jokes. 3d minus 21 equals 3. Then you can add 21 to both sides. Everything always to both sides of an equals in algebra. So 3d equals 24. You can divide by 3 then, and d will equal 8. Watch your steps, take your time. All right. Now, don't tune out at this point and say, okay, I got this, because these two are special, and you'll see something happening in a minute. You've got 2x. We try to take 2x away from both sides. Wait a minute. That means it's gone over here, and it's also gone over here, and it should bother you because 5 doesn't equal -3. It's a false statement. When it's a false statement, it means that there's no x in the whole world that's going to make this thing work. There's no solution. Sometimes you can just write a circle slash if you want to rather than writing out the word no solution, but it means nothing's going to work. Over here, oh, we could try to move over, but we've got these, this has to be taken care of. We need to distribute this 3 before we can go on. You've got 3x plus 3 minus 5 equals 3x minus 2. When we try to simplify this further, we get 3x minus 2 equals 3x minus 2. Wait a minute, those are exactly the same thing. So when I try to take away 3x from both sides, I get negative 2 equals negative 2. Well, that's true all the time. Since it's true all the time, no matter what number you would pick for x would work, so you would say that all numbers are solutions. Not just some numbers, but all the numbers are solutions. And that's the other special thing that you can have happen here. I just want to hit just one more thing you can do. If you have like a negative 2x and you don't like working with the negative so much, you are allowed to add to both sides as well. So if you wanted to, you could eliminate it from this side so that we have 3 equals 17 plus 5x. We'll take away our 17 from both sides so that our 5x equals negative 14, starting at positive 3, going 17 to the left. Then divide by 5. So your answer would give you 2 4/5. Or actually negative 2 4/5. I just did that to simplify it. So there you go. There's your examples of solving equations that have variables on both sides. Work carefully. Don't forget to show your steps. You know who you are that doesn't do that, so just please make sure you're showing your steps. But I do appreciate that you made yourself show your steps, and hopefully you see now why it's important. And I hope that this made a whole lot of sense to you, and have a very wonderful, blessed conclusion to your day. Just